Okay, this is answer key for exercise set 1.4. First one, we have a function, square root of x minus 2, and we're looking for the area from 2 to 6, so from here to here. Using this again, this is Riemann sums. Riemann sums. Okay. Approximate the area. How reasonable is your result? So again, I guess conceptually a good thing to think about here is the area of a rectangle is base times height. So I'm looking for the bases of all these. Now I can see it because I'm kind of by one. These are all just one, the bases. So I don't really care about the bases. I care about the heights. So I want to know the height of this, the height of this, the height of this, the height of this, the height of this. Again, visually you can kind of guess from the graph, but we don't want to be guessing. We want to be very accurate. So you're actually going to want to find the height of these by plugging in the midpoints of these. If you look closely, right, at the graph, it's not at the left, it's not at the right, it's in the middle, which means that when I plug in 2.5, the height of this is f of 2.5, right? And then same thing, when I plug in 3.5, that'll give me the height. When I plug in 4.5, that'll give me the height. When I plug in 5.5, right? This is 3.5, this is 4.5, this is 5.5. Okay. So I'm going to add those together. F of 2.5 plus F of 3.5 plus F of 4.5 plus F of 5.5. Remember, I don't care about the base because the bases are all one. If I had a base of 2, then I'd have to multiply each of these by 2, but I don't have to, so I don't need to. Then I'm just going to evaluate these. So I'm going to evaluate them by just plugging in 2.5 in for x. So, for example, on the calculator, I would do the square root of 2.5 minus 2 equals zero point 0.7. Okay, well, 0.71. 0.71 plus, same thing for the next one, going to do square root of 3.5 minus 2 is 1.2 plus square root of 4.5 minus 2 is 1.6, so 1.58. And then square root of 5.5 minus 2 is 1.8, 1.9, 1.87. In hindsight, I would probably have consistently rounded to 2 digits. But this is fine for now. So I'm going to add 1.6 plus 1.2 plus 0.71, and I'm getting about 5.38 is what I got for this. 5.38 units squared. That is the sum of these. How reasonable? I mean, that seems fairly reasonable to me. It does look like we are overestimating slightly. Um, I can tell I'm overestimating visually because if you look at this area right here over the curve, does look larger than this area under the curve. And then likewise here, this area here does look larger than this area under the curve here. And again, that has to do with the concavity of it. Because it's steeper at the beginning, we cover more of the area here. As it gets shallower here, we cover less here. Okay. Okay. So this is summation. This is from Toolkit 1.3. Expand and evaluate each of the following sums. So again, this is our beginning. This is our end. So you're going to do -4 squared plus -3 squared plus -2 squared plus -1 squared plus 0 squared plus 1 squared plus 2 squared plus 3 squared plus 4 squared. Okay. That's it. And that equals, well, I can kind of find this and double it. So it's 1 plus 4 plus 9. It's 5. It's 14 plus 16. That's 30 times 2 is 60. Right? I can times it by 2 because 2 squared, 1 squared, 3 squared, and 4 squared are all the same thing. Let me just double check that, make sure I got that right. 16 plus 9 plus 4. Oh, my bad. It's 29, not 60. That's my bad. So this would be 58. Okay. Because that's 16. Oh, sorry, plus the 1. No, no, it is 60. It is 60. Because the 1 as well. So 1 plus 4, 5, 9. At 30 times 2 is 60. Okay. Here we have cubed. So, but very similar, except you're cubing now. Negative 4 cubed plus negative 3 cubed plus negative 2 cubed plus negative 1 cubed plus 0 cubed plus 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed. So for this one, it actually equals 0. And the reason for that is because it's odd. So we talked about odd and even before, but if you think about this visually, 1 cubed is 1. Negative 1 cubed is negative 1. So these are canceling each other out continuously because this is negative 8, this is positive 8. So these are continuously canceling out because I start at negative 4 and I end at 4, which are symmetric, right? Negative 4 and 4 are symmetric. This is going to equal 0. Like I know that. 2 to the p. So here you're just replacing the p with your index instead of the variable, instead of the base. So it's the exponent instead of the base. So we have 2 to the negative third plus 2 to the negative second plus 2 to the negative first plus 2 to the 0 plus 2 to the first plus 2 to the second plus 2 to the third. So that's 2 to the third is, this is 8, this is 4, this is 2, this is 1, this is 1 over 2, this is 1 over 4, and this is 1 over 8. So together we have 8, 10, 14, 15 and a half, and a 3/4, and a 7/8. So this is 7/8 right here. Plus 15. Yeah, so 15 and 7/8 would be the total there. Okay, then we have sine. Okay, so sine, we're going to work on some trig after unit 1, but sine is an odd function. If we look at it visually, like sine of 0 is 0, and it's the same either way. So in the same way that this came out to 0, this is also going to come out to 0 because sine of negative 5 cancels out sine of 5, if that makes sense. But again, you do the same thing. It would be sine negative 5 plus sine negative 4 plus sine negative 3 plus sine negative 2 dot dot dot. I'm just going dot dot dot. Just keep on going until you get plus sine 5, but it's going to be 0 because of the reason I stated. It's odd, meaning that, look, negative 1 and 1 would cancel, right? Okay. 213. A bug is walking your paper along the x-axis. The bug's velocity is shown in the graph at right when the bug turn around. So if you think about it like this is the bug. If we have, let's say we have kind of a visual over here. Let's say the bug starts right here. In this part, the bug's like moving quickly, and then it's kind of like slowing down a little bit, and then right here, it's turning around at this 8 because the velocity is going from positive to negative. So this is kind of a rough visual of what the bug was doing, if you can imagine that, with time. So it kind of started here, it moved, and then it turned around, it went negative. So at 8 seconds, it's going to turn around because it's going, velocity is negative. Velocity is turns negative. Okay. When was it greatest? You can see visually right here at 2 seconds in, it was greatest. That was when it was highest. Actually, you know what? Looking at this, it was highest positive wise at this point, but down here at 12 seconds, if you look, it actually hits -6. So if you imagine like negative velocity is still speed. So actually, this is 12, not because of this was -6, and up here was 4. So -6, like the magnitude is greater, right? It doesn't matter that I'm going backwards at 6, whatever, 6 feet per second, right? So what is measured? I'm going backwards at 6 feet per second. That's still faster than going forwards at 4 feet per second. So actually, it was greatest at 12. It's kind of a tricky question. After 12 seconds, how far is the bug from starting position? So the hint is find the difference in areas. So this is like the negative, right? So this area right here represents this period where it went backwards. So this is a triangle, so it's kind of easy to find. It's 4 by what looks like 6. So 4 times 6 is 24. So the area of this is 12. 6 times 4 is 24. Divided by 2 is 12. So that area is 12. That's kind of our negative value. And then we need to find our positive value. So again, I can do this with triangles and kind of squares. I can kind of chop it up. So here I have 2 by 4. So 2 times 4 is 8. So this is 4 right here, because 2 times 4 is 8, divided by 2 is 4. This one is 2 by 4-ish. Again, it's kind of hard to see exactly. You could say maybe 3.8. And then this one is, see, it's kind of hard to say because that's just below 4. So I would say this is sort of 2 by 3.8. 2 by 3.8 is, this is 7.6 divided by 2 is, that's 3.8 here. And then, sorry, this one's 3.8 here. And then this one is, because it's a square, this one is 7.6. So I'm kind of just segmenting this out and finding the areas of these little segments. This is 4 here. And then this one is going to be, we can kind of estimate this one as, it's kind of 4 by 2. You could kind of guess this was 8 minus a little bit there. You could be more accurate than I'm being, but just based on visual, we can call that 8. So at 8 plus 7.6 plus 3.8 plus 4, so let me add them all together, 7.6. And so I got 31, total distance traveled 31.4, but then minus the 12. So I got total distance being 19.4 feet. Okay. I don't have that much time left on this video. I'm going to answer these on the paper. So you can see these. These two are equal. I mean, I'll talk about these for a little bit, and then I will write it out on the paper. These two are equal. This one, I'll show you the approach statements for this on the area, and then this one, I have a minute and 30 seconds left in this video, so I'll do the last one. So you have graph here. We have 2x plus 3. So you imagine visually, we're up here at like 0, 3, and we have, so it's 2x going up through it, and I'm looking for from kind of 5 to 7. You can say that. So 5 to 7 here. I'm looking for this. It's not the best drawing in the world because I kind of didn't quite manage it right. But I'm looking for this area from 5 to 7, and this is 2x plus 3. So what's the area? So the hint is to what's the shape. So again, kind of like how with the bug problem, how I sort of segmented it, you can segment this into 2 different shapes. So I have a kind of a rectangle here and then a triangle on top. So the rectangle is going to be 2 by, I'm going to plug 5 into this. 5 times 2 is 10 by 13. And then this one is going to be, again, 2 by, so the area of this one is 26. 2 by 14 plus 3 is 17. This is 4. 4 times 2 is 8. This is 4. It's 30. Okay.